Hello class 11th. In the previous lecture we were discussing about the numerical problem for cross vector means vector product, and then we have discussed about the geometrical interpretation and some relative velocity. The cross product we have seen the twice. Geometrical interpretation is not a very big deal, but relative velocity you must remember that if the two objects are moving in the same direction with velocity VA and VB such that VA is equal to VB, both of them are having same velocity, at this time relative velocity will be 0. Relative velocity means what? The difference of their velocity, so difference will be 0. Second, if one is moving in this direction and the other one is moving in the opposite direction, so in the vector quantity, velocity is a vector quantity, so it will be negative. So here resultant velocity will be VA minus VB, because this one is in opposite direction. So relative velocity will be VA plus VB. Third thing is, suppose VA is having velocity smaller than VB, both of them in same direction like here, but here VB is greater than VA. In this case the relative velocity will be VB minus VA. Instead we can say difference, so VB difference VA or VA difference VB, but here exactly we know that VB is greater than VA, so we can write directly that VB minus VA. Now the next topic is about the relative velocity again, but a new case. Suppose this man is moving in this direction with velocity Vm. Suppose this man is moving in this direction and here it is raining. So due to the effect of rain, because the rain will be pushing him down, man is going in forward direction. So at that time what will be the resultant velocity of the man? Let's calculate this. So for that, as you have seen, I am considering that the man is moving in this direction. This is man, and the rain is falling from the clouds in this direction, not straight, it is forming in this direction. So let's write this is Vm as for man, and this one VR as for rain. So what will be the resultant in this case? As we know that definitely the man means there must be a difference in the velocity. If the velocity of man is greater, so resultant will be in this direction. If the velocity of rain is greater, then the resultant will be in this direction maybe. So it is not exactly how to draw the resultant. So we can do one thing, that instead of taking Vm in this direction, why not we are taking the Vm in this direction? But at this time you will say it's a vector quantity. Okay, take negative sign, and Vr is always in this direction, we are not changing that. Now it is very clear that here in between them we can draw the resultant. So very easy, just draw the dotted line and find where they are meeting. This point will be there, the resultant point. So this is VR, this is the resultant, so we may have confusion which VR it is. So let's change this VR as V small r as for rain, and V capital R for resultant. I am just changing the symbols. V small r means for rain, V capital R means for resultant. Let the VR vector and the resultant vectors are making angle theta, and this will be 90 minus theta, doesn't matter. Now what is our purpose? We have to find the resultant velocity. The man is moving in this direction, the rain is falling in this direction. What will be the resultant velocity? Suppose you are riding a bicycle and huge wind is coming, rain is also falling, but rain is not straight, the rain is at some angle, then at that time what you will be there? So we can resolve the component, we can solve this type of questions easily. That is why I am giving the simple diagram how to solve first. Now forget about this, keep it aside and think about vector, suppose A and vector B. Both of them are having angle theta and not and their resultant, if you remember that the parallelogram law of vector addition, the resultant was somewhere here like that, and this was alpha. Actually this was making theta and many more topics, because this one is theta, we can take it here, and many more things were there. Resultant was there at that time. The resultant, remember, the resultant was vector A in the form of vector. We can write vector A plus vector B, and simply in the magnitude form we can write A square plus B square plus 2AB cos theta, if you remember that. Here in this case, in place of vector A I am taking VR, in place of vector B I am taking VM, and cos theta, the angle between these two, don't think that this is the theta. What is theta? The angle between the two vectors. What are the vectors? VR and VM. So what is the angle between them? Angle between VR and VM, exactly 90, and cos 90 is 0. So cos 90 will be here in this case, not here. I'm talking about this case. So I'm just separating the line. In this case, what we can write? VR resultant in vector form is equal to V small r for rain plus V M in the vector form, but what is the sign here? Negative. So write it here, negative. Now the resultant velocity VR in the form of magnitude under root C A square. What is A? VR. So write VR square plus vector B. What is negative VM? Square of that will be positive. VM square plus 2 VR, not capital, small, into minus VM into cos theta. Theta means angle between two vectors. What are the vectors? Again I am speaking 90. So cos 90, and cos 90 value 0 means this component is going to be clean. Only remains what? VR is equal to VR square plus VM square, or simply we can also write in the form of that without root value, that VR square, the resultant value, is equal to V small r square, rain square, and man velocity square. And let's find this tan theta, the angle between them. Let's use the tan theta, that is perpendicular upon base. From here, this is perpendicular. We can say which one is this? The VM, and divided by perpendicular, this is VR smaller. Now you might be thinking that why I am not writing negative sign. The negative gives only about the direction. We are writing this because to find the magnitude, the angle is not going to be negative. The angle value is not going to be negative. Here this is the magnitude. The magnitude says VM. The negative sign gives about the information about the direction. So theta is equal to what? VM upon VR. Now again I want to help you. If you remember the resultant angle, we can solve that with this equation. If you remember that alpha, sorry, not alpha only, tan alpha and what is the angle between the two vectors? 90. Fill here. B sin 90 upon A plus B cos 90. Again, what you will get? Cos 90 0. So this component is going to be 0. B sin 90, sin 90 value 1. What you are getting? B upon A only. What is B here? VA. What is A here? VR. Same thing here. You are getting again. The next topic is about the river problem. That someone want to cross the river, and then there are many type of way how to cross the river. So let's see different type of way, like minimum time and minimum distance. Let's see. So consider one river. This river has width, suppose small b. Then from here, the point A, the man is going to cross the river. But he thought, instead of going straight, because the river is flowing with some velocity, consider the river is flowing in this direction with velocity VR. See, at that time VR was about for the rain. I am here taking VR for the river. So in this direction the river is flowing. So suppose if someone is going to cross this river, so it will be pushed in this direction. So starting from here, I am taking that this person is moving to cross this river from here to here in this direction with velocity v. See this, the man is going in this direction with velocity v, and let this angle be theta. This VR is the velocity for the river. This v is the velocity of a man. You can write with velocity v it is flowing, and we can take Vm also. And this direction, in this direction the river. So the velocity component in the river direction of river. So that will be, this is theta. So this will be v cos theta. And one more component will be here for the in this direction, because the man not only in going forward direction but also is going in the ahead in this direction also. So this will be what? V sin theta. Definitely V, then V cos theta and V sin theta. V is the resultant velocity which is going in this direction, and VR is our velocity for the river. Now the topic that with which velocity in this direction it is moving, that V sin theta. This is the velocity of man, person who is going to cross the river, but the velocity of the man will be V sin theta if the person is crossing the river perpendicularly, and if the person is moving with the river in the direction of flow of river, so that will be V cos theta plus VR. VR is what? The velocity of river, and V cos theta is the component of the person who is component of the velocity of the person. So here it will be in direction of flow. See clearly, this is the velocity component perpendicular to the flow of river, and this will be the velocity of component of velocity in the direction of flow of river. So it creates the two cases, that if the person wants to cross this river in minimum time, suppose I want to cross this river, but I want to cross in the minimum time. So where should in which direction I should put my complete effort, or at which direction, at which angle I should swim? So we have to calculate time. So time is equal to displacement upon time. What is displacement here? We have to cross this B. Displacement upon velocity, I'm sorry. Time is equal to displacement upon velocity. So here our displacement is B. And what is the velocity here? That is V sin theta. We want this t in minimum, means we want the time as minimum as possible. So to create the numerator minimum, we have to create the denominator maximum. So for minimum t, v sin theta should be maximum. So v sin theta, this is the velocity of the person who can put his maximum effort, but sin theta maximum value 1. So this implies theta is what? 90. So if the person is going to swim exactly perpendicular in this direction, exactly perpendicular, see theta is 90, here is the theta. If theta will be 90, exactly perpendicular to the direction of flow of river, if the person flows, so that person will cover the distance in minimum time, not minimum distance. At this time, the person, when he goes straight, it doesn't mean that the river will be stationary or the water will be calm. The river is continuously pushing the person in this direction, because the river velocity has VR and the person is trying to go always perpendicular. The person is trying to flow. Suppose the person is from here, it is crossing the river perpendicularly, but the water will push him forward direction, in the direction of river. So when the person is going to cross this river, he was deciding to cover from A to capital B, but actually he will be at point C. Actually he will be at point C if the person is going perpendicular to the direction of flow. So one more question is there. BC, what will be the distance at that time? BC. So BC is what? Displacement. Displacement is equal to velocity into time. So velocity here is what? Maximum we are going to take, that is V, and time that we are going to take here, this is the time, the minimum. So let's calculate the that BC value. So BC, that distance covered in that direction, in that direction distance we are going to calculate. So distance is equal to, or displacement is equal to, velocity into time. In that direction, what is the velocity? C. In that direction, this is velocity, v cos theta and VR. See here. So v cos theta plus VR into what is time here? We are taking the minimum time, small t. Now let's multiply. And what about angle? Theta is what? 90. Let's fill here. V cos 90 plus VR multiplied with time, cos 90 value 0. Then what is remaining here? VR into time. And I must explain one more point. When theta will be 90, so sin 90 will be 1. So T minimum, the minimum time will be what? B upon V. So this value will give you the minimum time, and here this T is what? This T is minimum. So let's fill the value here. What you will get? VR into B upon V. This is like relative velocity, relative velocity of the river, velocity of the person, and this B is what? Width of the river. This was the case when the person deciding to get to cross the river in the minimum time. Now the person is deciding to cross the river but with minimum distance, because you can see through this path, actually he is not going through this path, he is going through this path actually. So in this path he is covering the distance in minimum time, but if I want to cover the minimum distance will be what? This direct. But actually the river is pushing in this direction, so a person cannot say go directly because the VR is here. So instead of going in this direction, suppose the person is starting its swimming direction in this direction. Suppose in this direction he is swimming, so the river will push him and he will go at this point from A to B. Suppose the person is going in this direction, so it will go like this. The person is deciding to go in this direction, but the river will push him and he will go straight. The direction of flow will be in this direction and the destination point will be at point B. When he will reach at point B exactly, which is opposite to A, at this time you can say he is covering with the minimum distance. Let's see this thing now. For this case, the velocity of river in this direction, that was VR, and this is the direction of flow, that V cos theta and VR. The person is deciding to go straight, but here the component of that is V cos theta here in this direction, and here V sin theta. We have seen these things when he was swimming in this direction, but now it is very clear that the person should swim in this direction. If we want to go straight at point B, we can put our logic that the person, if deciding if want to go from A to B straight, he should swim in this direction. We all know with our common sense. But what should be at that time angle? So suppose he want to swim in this direction now. This is the complete angle. What should be that angle? We are going to calculate now. This is not the acute angle. In that last case, it was acute. Here, it is obtuse. So here, this component, suppose the river is not flowing. Suppose the river is not flowing, so he will go straight. But actually the river is flowing with what velocity? With this type of velocity. So we can say that if anyhow, this velocity, the component of the velocity of the person and the velocity of river, anyhow becomes 0, then means the person can swim. But we can't stop the river, but we can find the angle at which the resultant velocity, which is in this direction, may cancel. So what will be that? See here, V cos theta is equal to minus VR, or cos theta is equal to minus VR upon V, or simply theta is equal to cos inverse negative VR upon V. And hence we can calculate the angle, means the person has to flow in this direction. Suppose this is the velocity of the river, we can find that this is the velocity of the person. So using this equation, the person has to flow in this direction with this angle. Then the person can go straight from A to B. This is the minimum distance. So we can calculate the minimum distance, but we have to calculate also the time taken here. It is clear that at this time the time will be greater than the last one. So let's calculate for that. Before that, we have to calculate the resultant velocity. So along AB is equal to V sin theta equal to V under root 1 minus cos square theta is equal to cos square theta. See here, I am going to put this value. So V under root 1 minus, instead of cos square theta, we can write here minus VR upon V. So squaring will be positive. So VR square upon V square. Now when this will go inside, so what will be here? Under root V square minus VR square. This is the resultant velocity, V capital R, you can say. The resultant velocity will be this. Now the time, so time is equal to displacement upon velocity. Displacement is what? B, and the resultant velocity is this, under root V square, the person velocity, minus VR square, the river velocity. So here the time will be greater, it is very clear, but the distance will be minimum. So there are many questions based on it. So and the question is, especially in your book, question 8 and 9 also, I think. So you have to solve these questions. Inform me if you are facing problem, and next lecture we will discuss about projectile motion. Till then, thank you.